Okay, today we're going to look at an AIME problem that is from 2014. So it is about a cubic function given with the square root of 2014, right? So we assume that the three real roots, x1 is the smallest, x3 is the biggest. We try to find this quantity here, right? So of course, when you see a cubic equation, you never want to use the formula or try to derive it as a root. It's going to be a tedious process. A lot of times, if you're lucky, you can just try to find out from the coefficient. Maybe there's a simple solution like 1, 2, things like that. Some factor of the coefficient, right? Here, of course, it's not easy to do that. So let's first look at the coefficient here, the 4029. How is this related to 2014? All right, it's almost like a double. So if you double it, you're going to get 4028. But we have 29, so you need plus 1. All right, so there's some relation here. Let's take advantage of that. So let's try to rewrite it, all right? So by, let's use a symbol t to represent the square root of 2014. And let's try to rewrite the equation, right? So there's a common technique. That is, sometimes you want to swap the known and unknowns from your equation. Here, we try to find x, but what if we treat t as unknown, right? So we have an expression here. This is an equation in x. But what if we treat x as constant and treat t as a variable? Then notice that t in this case could be a quadratic equation because the highest degree is 2, not a cubic. So it's easy to work with. Okay, let's try that. So let's rearrange it as if we were to solve for t. Okay, here's the swap, the knowns and unknowns, right? So if you write it in terms of t, you're going to get a quadratic equation with x squared as a coefficient, right? How do we solve that quadratic equation, right? Usually you want to factor the coefficient here, right? So for those who are not familiar with this method, how to factor by looking at the factor of the coefficients, go check online. There's a lot of materials on that. But I give you a simple example. For example, x squared minus 5x plus 6 equals 0. How do we factor that? We look at the coefficient here. This is 1. This is 6. We try to factor it. It's 1, 1. 6, there's 2 ways, right? Maybe it's 1, 6 or 2, 3, right? Let's try 1, 6 first. You want to do a cross product. You get two numbers, which is 6 and 1. And you want to get a negative one, you put the 6 to be negative, right? So minus 6. Then you get a negative 1, negative 5 here. However, in order to do that, this has to be positive. And then positive 1 times 6, you're going to get a constant term is negative 6. This is not what you want. You want a positive 6. So 1, 6 factor does not work. Let's try 2 and 3. All right, let's erase this. Let's try 2 and 3. In this case, we try to get a negative 5. So how about put a negative sign here, right? So you got negative 3 here. You got negative 2, add up negative 5. Perfect. And this negative 2 and negative 3 equals 6. So we know the factor is x minus 2 times x minus 3 equals 0. All right? So here, we're going to solve it for this coefficient here, right? How do we factor x squared minus 2? That's probably just one way, right? How about this one? This one you have different ways of doing that. Let's try 2 squared and 1. How about that? If you do that, when you cross it, you're not going to get anything like a cubic here. In order to get a cubic, you probably want to put 1x here, right? Then this would be, let's say, 2x, right? Let's do that. Let's put 2x and x as a coefficient here. In order to get a negative x cubed, you probably want to put a negative sign here, right? This is a constant term. And here you're going to have another negative in order to cancel the 2x. So you got it. You got the factor. So the factor right now is going to be xt minus 1, right? For this term here. Remember, this x is considered as a coefficient here. This other one is going to be 2xt, right? Minus x squared minus 2, right? So that's going to be your factor, right? So let's rewrite this equation here, right? by factoring in terms of t. Let's do that, and we got this. Now, of course, we know that t is square root of 2014. We try to solve for x, not for t. So let's do that. So here you have either this equal to 0 or the other factor equal to 0. And then how about we solve for x for both cases, right? So you're going to go back and treat x as the unknown here, right? So treat x as unknown. So we're going to rewrite it in terms of x is unknown, these quadratic equations. You can solve it using quadratic formula here, right? So this is easy. This is x equal 1 over t. The other one, quadratic formula, would be x equal to 2a, a is 1, negative b, which is 2t, plus or minus square root of 4t squared, and then 4ab, which is plus 8, right? And then, of course, you can cancel 2 here. This where 4 becomes 2, all right? So you got it. So we're going to have either this or over here. We know that x1 is smaller, x3 is the biggest, so x3 must be this one, x1 is a negative number, this is positive number, this is positive number. We try to find the quantity, which is x2 times x1 plus x3. And when you add this up, this word goes away, and you're going to get 2 square root of 2014 times x2, which is 1 over, right? And then you cancel, you get 2, which is the final answer. So we got it, all right? So we solve the equation by rewrite it in terms of t, and solve for t, and then go back, turn around, and then solve for x. So this technique is actually quite common, all right? So hopefully you're going to be able to find other use cases for these techniques. But let's go ahead and try a second method, right? The other one is, because we know the cubic equation for any polynomial, if you know the rules, by the Vieta's formula, you know the relationship, when they add up by the coefficient here, right? And this is here because there's a 0 x term here, right? For the and for the constant, you're gonna get the product of equal to this. Now, by looking at this, you probably know that we already know that x1 is smallest, x3 is the biggest. When three numbers add up to a positive number, right? So you know that x3 must be positive, right? Because the biggest. If s3 is negative, or 3 negative number would become a negative number, right? So when x3 is positive here, but then the whole thing is negative, right? This is negative. So x1, x2 must be negative, which means x1 and x2 must be one positive, one negative. But x1 is smaller, so x1 must be smaller than 0, x2 must be bigger than 0, right? So we know that x1 is smaller than 0, x2 is bigger than 0. But how about y? How about this quantity that we try to find, right? Is this bigger than 0 or smaller than 0? We don't know, because x2 is positive. We don't know if x1 plus x3 is positive or negative, right? We don't know. However, when you look at the second term here, this is exactly y, right? So this is x2, this is exactly equal to y. And then x3, x1 is negative, because we know from earlier, this is positive, x3 is positive, this is negative, so y has to be greater than 0. Y is greater than 0. That's what we conclude from these three equations, right? Now, but we need to find y. How do we do that? Let's try to find an equation for y by looking at these three equations here, right? So when you look at it, I rewrite it a little bit, right? So in this term, because I noticed that this is just y, right? And here we don't have y, but we have x1, x3 shows up here, right? Okay. But how about this one? Right, this one is almost a y, right? I'm missing x2. All right, let's do that. Let's multiply x2 on both sides of the equation, right? So I'm going to have x2 here. Then this is your y here, right? So from the equation number 2, right? So we know from here, right? So we know that x1, x3 is equal negative y, right? From the equation number 2 here, right? And if you plug in here, what do you get? You get x2, right? You get a negative y times x2 equal negative 2 square root of 2014. Negative left cancels, and then you can express x2 in terms of y by dividing y on both sides. Is going to be here. Now we're getting close, because when you look at the first equation, it has only variable y, so the first term is y, and x2 squared and x2. So if you replace x2 with y, you get equation in y. All right, let's do that. Let's work on the algebra, right? By multiply x2 on both sides, and then you notice that this is y and this is y, and then this one you can express x2 in terms of y. All right, so we just let's do that, right? So let's this is earlier we said that y equal negative. From here we know that y equal negative x1 x3. Plug in here, so x2 equal 2 square root of 2014 divided by y, and then you plug into the first equation here, right? And what you get is you get a y and plus x2 squared, right? So it's going to be 4 divided by 2014 times y squared, right? Equal 4029 divided by square root of 2014 times x2, which is 2 over square root of 2014 times y, right? All right, let me erase that now. Okay, so let's multiply both sides by 2014 y squared. What do we get? Okay, multiply on both sides, so you're going to 2014 y to the cube plus 4 equal, this is going to be 2014, this is going to be y, so you're going to have 4029 times 2 times y, right? And then you can divide it by 2 on both sides. This is 1007. You're going to have this equation here. But how do we solve it? All right, here, even though it's a cubic equation, but we're going to try an arrow. So is 1 or negative 1, is 2 or negative 2 a root? You can try it. And if you do the algebra, you know that y equal 2 is a root, right? But how about the other two roots, right? So let's try to factor this, because right now we know 2 is a root for sure. It has a factor of y minus 2 here. But how do we know the rest of it, right? Times some quadratic equal to 0, right? This is how you do it. You do some algebra here. Since we know you have y minus 2, so you must have 1007y cubed minus 2 times 1007y squared. But there's no y squared term, so you have to cancel it, plus 1007y squared. And then you minus, because y minus 2 is a factor, so you have 4 times 1007y. And then here you have negative 4029. This is 4028. So we need to further minus y, and then plus 2 equals 0. This is, you rewrite this in terms of this term plus this term plus 3 terms, right? Now you can factor, which is y minus 2 is the factor, right? And then in the first term is 1 minus 2 times 1007y squared. And here is going to be 2 plus 2 times 1007y. And here is a minus 1, right? Equal 0. This is how you would factor that, right? So you factor this, and then from here you got a y equal 2. From here you can do the complete square here by looking at the 1007, and then y squared plus 2y plus 1, right? And then minus 1007 minus 1 equal to 0. So y would equal to 1007 y plus 1 squared equal 1008 divided over 1007. So y in this case is collective 1 plus minus square root of 1008 over 1007. You can make an argument that the correct answer we're looking for is y, which is x2 times x1 plus x3 here equal to 2 in this case, right? All right, so today we use two methods in solving an AIME problem. Hope you enjoy it and be able to find some other problems that you can apply the techniques we introduced here. All right, thank you.